Hello, welcome. Let's look at this episode 33. In this episode, we are picking the question to text the introduction episode we did on moments of forces. So we are to consider the diagram where we are to find the value of R1, R2, which are the normal reactions at the pivot. The pivot is Q and P. Now, in doing this, we have to ignore one of the pivot so that we can have the turning effect, or the balance, if you want to look at that. So let's see solution. So let's say taking moment at the point Q. Let's just say we are using Q. If we take moment in there, we are going to have two sides of the pivot where there will be clockwise movement for balance, then there will be anti-clockwise movement for balance. So let's check the two sides. So I have to consider the sum of, since I'm here, let's take the anti-clockwise movement. So if I want to find the anti-clockwise movement, remember as the pivot is here, it means we are going to ignore the value here, the P. We are ignoring the P. So in your mind, there is no P here. So we are going to see that if the bar tilts down, it will be tilting in the clockwise direction. This clockwise direction. Everything that goes along with it, the force 20 and 30 will all move down. Then as the force 30, 20 is moving down, the normal reaction is also moving up. So this is also clockwise movement. You can see as this one comes down in clockwise direction, it forces the red end to also move up. So both are moving in the clockwise direction. Then if we are tilting it down this way, that is the anti-clockwise direction. Then as this one goes down, the normal reaction too will also move in the anti-clockwise direction. So since we are seeing the sum of anti-clockwise, let's look at this. Now, moment is the product of the force in question and the line of force as in the direction. The distance, perpendicular distance between the pivot and that of the force. So the pivot is here, the distance between force 20 and the pivot is what? 4. So I'll be having 4 times what? 40. We are saying sum. So we add the next one with other force. This force is going. We are ignoring this because this will never go up. This is the only one that will go up because the center of gravity is here. But as we put the pivot here, the center of gravity will shift from here to somewhere here because the bar is now going to be elongated. Now what do? We are looking out for anti-clockwise, coming all the way from the pivot. From here to the normal reaction, it goes up. From here, normal reaction. So 2 plus this, 6. 6 times what? R. So I have 6R, which will give us 160 plus what? 6R2. That is the sum of all the anti-clockwise movement. Then let's look at for the second one, the sum of all the clockwise moments. So clockwise, let's begin with the R1, right? So R1 is here. It's going to move in the clockwise direction, but it is still at the pivot. So you can see that there is not going to be a distance. There is no displacement, no distance at all. So the distance for R1 will be 0. So 0 times R1 will give you 0. So first clockwise force is going to be, clockwise movement will be 0. Alright. Then from here, this force will move down. So 2 and 20 will move down. So 2 times 20 plus from here to here to here. This is moving down. So force 30 is moving all the way the distance of this is 9 meters away from what? The pivot. So that becomes 9 times what? 30. Can we compute this? Will have 40. This will have 270. 310. So we can say that from the principle of moment, we know that the sum of clockwise moment will be equals to sum of anti-clockwise moment. Let's say sum, so we add x to it. What is the clockwise moment? The clockwise moment is 310, should be equals to anti-clockwise 160 plus 6 normal reaction 2. So we subtract 160 from both sides. So 310 minus 160 equals to 6 R2. This will be giving us, is it 150? 150 plus this, yes. We have 150 equals to 6 R2 divided by 6. So R2 is going to be 6 go here, 2. So we have 2 remainder 3, 30, so 5. So we have 25 Newton for the normal reaction 2. Now how do we find the reaction 1? That is the normal reaction 1. We can also from the principle say that sum of the upward forces equals to the sum of the downward forces. For the bar or the rigid bar to be in equilibrium, the forces moving up and the forces coming down must balance. So if they balance, we have the upward force equals to downward force, because the clockwise force is taken as negative, and the anti-clockwise moment is taken as positive. So if we add the two equals to 0, that means they are in equilibrium. So we can transfer the negative clockwise to become positive to make sum of upward to be equals to the sum of the downward. So this one we can read out and do. What do? We are going to have R1 plus R2 should be equals to 40 as a downward force, 20 as downward force, and 30 as downward force. So what do? We compute this and continue. So right away, I'll be having R1 plus 25 equals to, this is 60, 90, right? 50, so we have 90. So R1 should be equals to 90 minus 25. So R1 will be 90 minus 25, it will give you 65 Newton. So you can see that this is what is going to be the answer. Now, this is not the only way we can go about it. Here, we were taking the moment at Q. We can also take the moment at P, ignoring the pivot Q. It means that at the first calculation, you will be eliminating the R2 and make use of R1 and come back to find the upward force equals to the downward force. The result will be the same. I guess you follow the concept. You can try that one, taking the moment at P, and share your findings in the comment section as we keep learning together. Like the video, subscribe to the channel, leave a comment, and share.